Good morning to everyone. Today we will be discussing atomic structure goal 3 Bohr's atomic model. This class is for Sri Chaitanya C3 C batch classes. So today we will be discussing the Bohr's model of atom. So first, before going to the Bohr's model of atom, we will be discussing what Rutherford's atomic model and get to know what were the drawbacks in the Rutherford's atomic model and the existence of spectral lines, what will help to solve the conflict between the conclusions. We will get to know all detail in this gear. So first, coming to Rutherford's atomic model, I'll tell you in one word. Listen, Rutherford's atomic model, it cannot explain the electromagnetic radiation. So, electromagnetic radiation, why it cannot explain? Because Rutherford's model, it is not even taken as the structure of a model, atom. Because electromagnetic radiations, they are useful for the emission and absorption of electrons. It helps for the existence of an atom. So that's why. Also, it was not able to account the existence of spectral lines even for the simplest atom. Also, spectral lines are also very important for the atom. So even it cannot, this is also second the drawback, it cannot even show the existence of the spectral lines in the simplest atom. Also, coming here, hydrogen spectrum, to seek the theoretical explanation, for seeking the theoretical explanations and the existence of spectral lines and their regularities, we have to solve the conflict between the conclusions of conventional mechanics and the laws of electrodynamics. So what they given here is hydrogen spectrum. We need to solve the, we need to seek the theoretical explanations. We should have a detailed information for the existence of spectral lines and the regularities. If we get to know, we can solve the conflict, means the difference, conflict difference, and we can able to solve the questions and the conventional mechanics using the conventional mechanics and the electrodynamics. These two are helpful. Next, here now we will coming to the chapter. What is that Bohr's model of atom? So coming to this, here this Rutherford said, why we got to know here Rutherford's atomic model? Because this Bohr, he is a scientist. He took this Rutherford atomic model and what were the drawbacks? Which were the drawbacks were there, like the electromagnetic radiation and the spectral lines were even for a like simple atom also it cannot form. So that's why Rutherford took the overcome of these drawbacks and it took a further step of this model. So he developed this Rutherford's atomic model. What he did, we'll get to know. That's why he explained the what were the Rutherford's atomic model drawbacks. So first, Bohr in 1913 what was the year 1913, put a forward theory to improve the Rutherford's model of atom structure of an atom. Here in the year 1913, Bohr was a scientist. So what is observed in 1913, he improved the theory of the Rutherford's model. Here this model, Rutherford's model, which were the drawbacks were there, he took that and he improved the model of the atom, like absorption and emission of the radiation. Here, Rutherford's atomic model and structure of the atom. Also, he improved the structure of the atom. Like Rutherford's atomic model, there were many drawbacks. Not these two, there were many drawbacks. So, he improved, he improved the model and the what were the drawbacks? He covered them. Like he solved. His theory was based on the principles of Max Planck. So, he took a theory and improved the atomic model. What was that? Max Planck. And about the absorption, here we will get to know absorption and emission in the next page. Okay, so first we will discuss, after that I will tell you in detail what is the meaning of absorption and emission and radiation of the radiation by an electron. Here he took the theory of the Max Planck and about the absorption and emission. Here he took the principle of Max Planck about the absorption and emission radiation by an electron. So thus he got to know what were the drawbacks in the Rutherford's atom and what was there to develop in that. Okay, we will come Now we will come to what Bohr did, what he discovered with what theory. Okay, in order to overcome the drawbacks of Rutherford's atomic model, Niels Bohr, a brilliant Danish physicist. Here, Niels Bohr, his full name is Niels Bohr. He was a brilliant Danish physicist. Okay, he was a brilliant Danish physicist. Okay, in order to overcome the drawbacks of the Rutherford's model of atom, so he overcome the drawbacks of Rutherford's atomic model. His name, what is his full name? His full name is Niels Bohr. He was a Danish physicist. Okay, he pointed out that old laws of physics just did not work in the submicroscopic world of the atom. He closely studied the behavior of electrons, radiation, and atomic spectra. Here, what he did means he pointed out the old laws of physics. He did not work in the submicroscope like observing the atoms, not like that. What he did, he closely observed inside. What he observed, how were the electrons behaving? What was the behaving of electrons? To gain stability, what they will do how that, like that only he found the emission and absorption, also radiations and atomic spectra. Okay, na? What, when he discovered in 1913, he proposed a new model of atom on the modern quantum theory. What theory he used? Quantum theory. And what he proposed? A new model. He proposed a new model based on this quantum theory. With this theoretical model, he was able to explain as to why the orbiting electron did not collapse into the nucleus, as the electrons which are revolving, why they did not collapse into the nucleus. Okay, and how the atomic spectra, you know what is atomic spectra? Atomic spectra, how it is formed, like this they gave in this picture. Atomic spectra by the radiation. To gain stability, the electrons will gain or lose emitting, but electrons moved from one orbit to another. Here what they gave, why an orbiting electron did not collapse into the nucleus, and how the atomic spectra were caused by the radiation emitted when electrons moved from one orbit to another. Here he developed so many things in this Rutherford's atomic model. How means, here when the electrons are revolving in the orbits, when they are transferred to one shell to another shell, how was the emitting radiation happened when they move to another orbit. Okay, next we will get, there are 7 here he gave 7 theories. We will discuss the detail in this class. So first, Bohr's postulates. So first point, what is the first theory? I'll explain you in this. Okay, here the nucleus, it is here electrons revolve. You know how sun revolves, how the planets revolve around the sun, like that these electrons moves in circular paths around the nucleus. Okay, in the specified circular paths, or they are also called as orbits or shells. Okay, these orbits are numbered as, we can number it as 1, 2, 3, 4, 5. Also we can represent it as K, L, M, N, O respectively, and are represented by N. So these are all represented by N. Okay, you understood? First, nucleus is present at the center. These electrons will revolve around the nucleus in a circular paths or the shells. They are numbered as, how many shells they gave here? 1, 2, 3, 4, 5 shells, like that. Also from here, 1 K, 2 L, 3 M, 4 N, 5 O, like that. Okay, now second theory, each shell associated with defined amount of energy, hence these orbits are also called as energy levels. So here how much amount of energy is present in these orbits, they will remain constant, they will not change their energy. Okay, they have defined and constant energy. That's why these orbits are also called as energy levels, the constant energy levels. Okay, next, third one, as long as the electron revolves in a particular path or orbit, the electron neither gains or nor loses energy. Therefore, these orbits are called stationary orbits or main energy states, and the electron is said to be stationary energy states. Here, what they gave is as long how may if we take the example of this L shell, if any electron revolves around this L shell, it will not even gain or lose energy. It will remain constant. Okay, na? Therefore, it is called as the stationary orbits or the main energy states. Okay, na? It has three names. What is that? Energy levels, stationary orbits, main energy. Remember these three names. Okay. These electrons are said to be the stationary energy states. Okay, now remember this. What are electrons called as stationary energy states? Next, fourth theory. What is the fourth theory? The energy associated with the energy levels increase. Here, how much the n value will increase, the energy associated in the energy levels will also increase. Okay, now if we increase in the number of shells, the energy associated will also be increased. Okay. Next. So coming to this fifth theory. So I told you, I will explain you about this absorption and emission of these electrons. I will tell you in detail here. Okay, I will tell you in simple words. So when you want to gain energy, what you will do? So first you absorb the energy. If you have more, okay, I'll tell you for an example. So first atom to gain stability, it should have 10 electrons. So what if it has 6? So it will become higher. We will take 2. If we take 2, to gain stability, it has to gain how much it has to gain? More 8 electrons. Means what we are observing here, it observes. So 2, it is the lower energy. So it is jumping. Like it is for lower energy level, it is going to the higher energy level to gain the stability. Okay. To gain the stability, it is going from lower energy to higher energy level. That is called as the absorption. Here, like this, electron also takes electrons from the other atom to gain the stability. That is called as the absorption. Okay. Next, coming to the emission. So for emission, when we have 6 electrons, to gain the stability, we need more 4. So not like that. Okay, when we have 14, to gain stability, 14 is more higher than the stability level. We should have only 10 electrons in the valency shell. So for 10, for getting 10, we have to lose more 4 electrons to get the stability. Yes or no? To gain the stability, we need to lose more 4 electrons. So, from going higher energy level to lower energy level to gain the stability is called as the emission. Okay? It is called as the emitting. Okay, no? Absorption means from going from lower energy to higher energy level. Emitting means from higher energy level to lower energy level. This absorption and emission, I told you, electromagnetic radiations takes place by the absorption and emission. Okay, na? Absorption and emission takes place due to the electromagnetic radiation. So, for example, we will take E2 as the lower energy. Okay, E2 as the lower energy and E1 as the E1 as the lower energy and E2 as the higher energy. Okay, H as the Planck's constant and nu as the frequency of radiation. What we will get? Delta E is the energy difference between two orbits. Okay, so first what we will do, we will subtract the higher energy from lower energy level, right? So we will take as E2 minus E1 is equals to delta E or is equals to H into mu. What is H? I told you, Planck's constant. Mu, frequency of radiation. Next, what is delta E? We will not get this point in every goal, so we have to underline it for remembering. Okay, Delta E is the energy difference between the two orbits. What is delta E? It is the difference here. What we did here? Higher energy orbit to lower energy orbit. That is only the energy difference between the two orbits. Easy. Okay, na? What is H value in joules and ergs? Do you know? It is the value of 6.625 into 10 power minus 34 joules per second, and 6.6256 into 10 power minus 27 ergs. Okay, it has two formulas for in x and joules. Remember it. Next, coming to sixth theory, the angular momentum of an electron revolving in a particular orbit is quantized and in an integral multiple. Here, angular momentum, this is just the formula for this. Okay, na? When it is revolving in a particular path, okay, na? It is quantized and it is integral multiple of, what is its multiple? Of h by 2 pi. It is known as quantization of angular momentum. What is this called as? Quantization of angular momentum. Coming to the last seventh theory, the angular momentum is given by the formula as mvr is equals to n into h by 2 pi. Also we can write this n into h by 2 pi as nh by 2 pi. Anyway, we will get the same answer. Okay, so first angular momentum is given. What is m? M is the mass of the electron, and what is v? V is the velocity of the electron, and r it is the distance of the electron from the nucleus. Here we got no picture. What is the picture that they have given here? What is the distance if the electron is revolving in the shell of M? So what is the distance between this nucleus and the M shell? That is the value. That is the distance, means that is the R value. Okay. M means mass, V means velocity, R means distance. It is equals to N. N is the numerical value. It will change. It will not remain constant. It will change time to time. What they will mention in the question, that we have to substitute in the formula. H value we know. What is H? Planck's constant. 2 by 2 pi. It is called as Bohr's quantum condition. What it is called as? Bohr's quantum condition. Okay, we'll meet in next class. Thank you.